Hi, welcome to Math Smart. We'll be talking about factoring today, factoring algebraic expressions. We must be familiar about the concept of factoring, or as factors, how do we deal with numbers? We have to remember a few concepts before we start factoring algebraic expressions. The concept of factors and multiples is very important for us to remember. Now, what are factors? If I give you examples of some factors, let's say I take example of a number 6. What are the factors of number 6? By factors, I mean the numbers I can use to divide 6. What are the examples of factors of 6? I can divide 6 by a number 1 or 2 or 3 or 6 itself. So a number can have many factors. Same way, if I talk about the multiples of the number 6, the multiples of number 6 can be any number I get when I count by 6, or the numbers that I receive or that I get in the 6 times table. What are those numbers? Let's take a look. It can be a 6, as it is 6 times 1. It can be a 12, 6 times 2. 6 times 3 is 18. And if you continue to extend the list, you will have unlimited number of multiples for any number. Let's say for number 6, it doesn't stop at 60. For example, 6 times 10 makes 60. It can also be extended to 66 and 72. So these are the two simple things that we need to remember about what the factors and multiples are. Now, what do we do in factoring the expressions? So when we are dealing with factoring the expressions, we try to find out what are the common numbers or variables in the given terms that we can use to divide all the terms of the expression. It's quite possible that some of the terms can have many things common, some of them cannot have anything common, some of them can have some things common. So how do we deal with these situations? Let's take a look to next example. So the example that I have taken to start with is a very simple binomial, that's 4 times x plus 16. If you notice, we have discussed about how do we identify the terms of a binomial, and that's why we call it a binomial. It has two terms. It has 4 times x added to 16. Now, how do we start finding the factors of this expression? We first start looking at the coefficients. The coefficients over here are 4 and the constant 16. So the numbers we first focus on, what can be the common number that I can divide 4 and 16 by? So if I see the factors of 4, the factors of 4 are 1, it can be a 2, it can be a 4. If I try to find out the factors of 16, it can be a 1, it can be a 2, 4, 8, or it can also be a 16 itself. Now, what do you notice? Both the numbers have some of the common factors. What is the factor that I should be choosing to divide these two numbers? So my focus should always be on the factor that is common, and it is the largest common factor. We also call this greatest common factor, known as GCF. So I can write this as GCF, which stands for greatest common factor. So I have found the greatest common factor for my two numbers, 4 and 16. Now my next focus will be the variables that are present in the terms. Over here, it's pretty simple. I can see only one of the terms has an x. The other term doesn't have any variable. So my task is quite simple. What I have to think is, how do I divide both of my terms by a 4, and what do I get as a result? So let me show you the next step. When you divide both these terms by 4, you divide 4 times x by a 4. So you get x remaining, which is inside the bracket. The 4 has come out. That shows that I have divided the first and the second term by 4. And now if I see the result of this division on my second term was 16. And when I divided my second term by a 4, it has changed to a 4 only. So over here, I have got two factors of my expression. The two factors are a 4 and the bracket. Let me remind you, the factors are those numbers or expressions which we multiply to get the result back. So if I see when I multiply these two factors, I get my same expression back again. So my two factors are 4 and x plus 4. So over here, this was a very simple example to start with the concept of factoring using algebraic expressions. Let's try to extend the thinking a little bit. We have two terms again. We're having 3x squared and 15x. If you notice here, there's a slight difference. In my previous example, we did not have a variable in both the terms. Over here, I have something common as a number and as a variable for both of my terms. So how do I deal with that situation? So let's take a look and let's compare the common terms, that's common numbers and variables for both the terms again. So once again, let's start with writing the common factors for 3. It's a 1, it's a 3. So it's a small number, so we have just two factors for 3. Let's try to find out the factors for 15, and then we will figure out the common factors. A 15 can be divided by a 1. That's a factor for all the numbers. I can divide 15 by a 3. I can divide a 15 by a 5. And finally, I can divide a 15 by 15 itself. Remember, I have to choose only the greatest common factor. So I pick the common factor 3 here. That's common, and that's the greatest common factor as well. Now my focus shifts on the variable. When I compare the variables here, in my first term, I see x times another x. While in my second term, I just have a single x. So that's pretty obvious that there's only one x that's common in both the terms. So my factor will be a combination of the number and the variable that are common in both of my terms. So how do I write my common factor? It will be 3 times x. And what will be the impact of this common factor on both of my terms? Take a look. I have divided 3 times x squared by 3 times x. So when a 3 is divided by 3, a 1 remains, and it's not required to show a 1 with a variable. So I have only an x left behind in the bracket for the first term. While if I divide a 15 by a 3, I'll have a 5. And if I divide the x by the x itself, I will have no variable left. This is how I got my two factors again, which are 3 times x and x plus 5. Wow, this is a little different and complex example of factoring. What are the differences? If you notice that we are moving to one step ahead each time, dealing with different concepts and different additions to the binomials while we are factoring. So let me write down here, let me identify the differences here. So there are these things present in this expression. One is a sign, because the previous examples that I have taken were both positive terms. Over here, I have a negative term, first and second both. So there is a new sign involved. I have coefficients. I also have x. I also have a y. So there are 4 things that I have to notice here while I'm taking something common for my factors. And if you remember, I have discussed with you before in my previous videos, whenever you are dealing with algebraic expressions, whether you're multiplying them or dividing them, you must take the 3 steps. The 3 steps should be: look at the signs first, deal with the coefficients, and then deal with the variables. So we will be choosing here those 4 steps because we have 2 variables to find the factors of this expression. So now, if I say I have to find the factors of 15 and 14. Let's try to simplify by writing. So my factors for 15 would be, again, starting with 1, I have a 3, I have a 5, and then I have a 15. Then, what are the factors of 40? The factors of 40 are 1, 2, 4. What else? It can be 5. Yes, it can be 8. It can be a 10. It can be a 20. It can be a 40. Now, it has a long list of factors. It can be divided by so many numbers. Now, what is the common factor for 15? Common factor for 40, 15, and 40 would be 5. That's pretty obvious here. I'll choose the 5 here as my common factor. Oh, one moment. Let me just highlight that. Yes, I've chosen my number 5. But now I take you back to my previous example where I was talking about sign. So what will be the sign of the two numbers or the same number factor that I've chosen 5? Would I be dividing by a positive 5 or a negative 5? So here I'll say, since both my numbers which I'm dividing are negative 15 and negative 40, I'll prefer to choose it by a negative 5, since both the negative numbers can be divisible by a negative number also. So I write here, finally, the factor for the two numbers would be a negative 5. Okay, now let me focus on the variables. The variables, x variables in the first expression are x times another x. And in my second expression, I just have a single x. So as I mentioned before, when I have just one x common, I'll pick the common x for my factor. And then if I focus on the y's, my first expression has a y, my second expression has a y times another y. So what is the common number of y's in these two? I have just one single y. So I just pick that. And together, what do they make? So they will make a negative 5 times x times y. Let's see the impact of this common factor on the two terms when I divide both of them by negative 5 times x times y. Can you guess the answer? Take a look. I divided my negative 15 by negative 5. I got a 3 remaining. I divided my x squared by another x. I got x remaining. But when I divided my y with the other y, there was no y left in the first term. The impact on the second term was also the same. A negative number 40 divided by a negative 5 gave me a positive 8. X divided by another x did not leave any x behind. And when I divided the y squared by y, I still have a y left. So my factors are pretty simple. I got a negative 5 times xy as my first factor, and my second factor was 3 times x plus 8y. Now I hope these three examples in the increasing order of complexity have made the concept a little more clear for you, and my videos have helped you, I hope. Keep watching Math Smart by Anjali, like and subscribe, and I'll be coming with more help for you. Thank you.